This is absolutely a question where I would arithmetize. I'm going to make up numbers for these variables because this is dangerous. They're asking us to change things. The mass is changing. The energy is staying the same. We're comparing velocities, but we don't have any numbers to compare. Math is much easier if we can see a number increase or decrease, and so we want to have real numbers. Don't just think about this abstractly. So when we do this, because there are two different objects, we've got to keep track of everything. Let's start with object 1. What do we know about it? Well, we're going to eventually find some energy for it. But we do know that it's going to have a mass that we're later going to take 1/2 of, right? They say an object has the same kinetic energy as a second object with half the mass. So for this first object, let's make the mass something like 2, which I can then take 1/2 of later very easily, right? So it's a way of kind of avoiding the fraction if possible. That's what we want to do. Now I'm going to make the velocity equal to 1, and the reason for that is all of these answer choices are looking to compare the ratio of the first object to the second. So if I'm looking at the velocity of these two things, then I might as well make the velocity 1 so that it matches up with the 1 in all the answer choices. And that lets me solve for the energy. So in this case, energy will be 1/2 of 2, which is 1, times 1 squared, which is just 1. So the energy of this object is 1. Now I have a second object that has the same energy, so that is going to be 1. It's going to have half the mass, so that's 1, and we're trying to solve for the velocity. That way we can compare the two. So here we just need to kind of clean up this algebra. So what would I do? Well, I want to get v alone. The 1 isn't going to matter, and in order to get rid of a half, I multiply both sides by 2. And so I'm going to get 2 is equal to v squared. And then, well, just take the square root of both sides. And so v is equal to the square root of 2. So what is the relationship between the two velocities? Well, we said before the velocity was 1. Now it's root 2. So comparing them, we get that it's 1 to root 2. That is easy to understand when we have actual numbers. In fact, I don't even care that root 2 is such a weird concept. I'm okay with it because the numbers proved it for me. Maybe you could have just thought about this and gotten that right, but it's so risky on the SAT because they know where your brain is likely to make a mistake, and the wrong answers are going to reflect that. So we have to be really cautious, and having numbers, arithmetizing, helps us avoid these kinds of traps that the SAT is setting for us.